Okay, from yesterday. First of all, any question that you want to ask me about exercise 23A, 23B? Any question that you want me to do first? Okay, okay. No, then we shall continue. So, the next one that we want to look at is called root of unity. Okay, root of unity. So, it's actually extensions of the DMT2. Okay, from DMT2. So, let us first recall what is DMT2. Okay, if Zn equals REI theta, then what? Anyone can fill it in for me? Then what? From DMT2. Anyone?
Is it the div over n thing?
Mm-hmm. Yes. You have to understand this rule from DMT2. What do we have here?
It'll be about the roots, right?
Yes, yes. You need to fill in, give me the result. If this, then what?
Zk
Mm-hmm.
equals to r to the power 1 over n
Mm-hmm.
times e to the power I
Mm-hmm.
in brackets theta over n
Mm-hmm.
plus 2k pi over n.
And what do we say about the K?
Uh, it starts from 0
Mm-hmm. And
and
with?
then
And with what?
uh, n minus 1.
N minus 1. Okay. So your total of n roots here. Okay, your total of n roots here. So from the MT1. So from the MT1, there will be some special properties that actually can appear. Okay, number one, okay, let's the best is actually we look at the result. Okay, simple case. Well, let's look at the simple case first. So z cube equals to 1. Let's say z cube equals to 1. So if z cube equals to 1, okay, then I will have zk equals to 1 will be referring to 1ei0. Okay, 1ei0. So I have a ei of 2k pi over n over 3. Okay, so that means I will have 3 root z naught equals to ei 0. Okay, z1 equals to ei 2 pi over 3, and z2 equals to ei 4 pi over 3. Okay, so of course this answers is written in the Euler form. Let's say we change it back to the modulus argument form. Modulus argument form. Okay, so I will have z naught equals to cos of 0 plus I sine of 0. Z of 1 will be cos of 2 pi over 3 plus I of sine 2 pi over 3. And z of 2 equals to cos of 4 pi over 3 plus I sine of 4 pi over 3. Do you agree?
Yes.
Okay. Let's see what is the result that we get if we change it further into a real imaginary form. Real imaginary form, this will be 1, this will be 0. Okay. And this will be cos of 2 pi over 3, cos of 120 degree. You have a negative half plus square root 3 over 2i. Okay, this one I have a negative half minus square root 3 over 2i. Okay, So we have able to see all three answers in three different forms. Okay, the next part that we're going to look at is what happens if we put them into into Argand diagram, real and imaginary. Okay, so I will notice that Z0 will be here, Z1 will be here, Z2 will be here. Anyone can tell me what can you observe from these three locations?
Oh, do they form an isosceles triangle?
Isosceles?
For this one, yes.
Is an equilateral triangle.
Oh, equilateral, I see.
If we join the connections from the center, anyone can tell me what can you observe?
The distance is the same.
The distance is how much?
Oh, the magnitude is 1.
The magnitude is 1. Of course, the distance is the same. Anything else can you observe?
The points are equidistant
The points are equal distance.
from
Okay.
each other.
Oh, yes. Therefore, it's an equilateral triangle.
Oh, yeah. Is it something to do with the area?
Area, something else? Something that related to the center here. Anything else you can observe? It gives you 120 degree. It gives you 120 degree. Can you see that?
Oh, yes.
This 120 degree is exactly your 2k pi over 3. Okay, so we have few conclusions that we can make. First, a regular polygon. Okay, same angle, same length, same modulus. Okay, let's see what happens if I change the questions. Oh, no, sorry, not yet. Second thing that we want to observe is what happens if I sum these three numbers together, these three roots together.
You get 2. Oh, wait, no, you get 0.
You get 0. Do you see that you can actually, you get 0? Anyone? Can you see that you get 0?
Yes.
So, in other words, Z1 plus Z2 will be equals to -1. Agree?
Yes.
Okay. So, okay, this is the first observation. This is the second observation. There is a third observation. Now you can take out your calculator. Okay, Z0 itself, if I power 1, of course I have 1. Z0 power 2, I will also get 1. Z0 power 3 also get 1 because the value 1 itself, right? So nothing special about this. So what interesting is Z1 and Z2. Z1 power 1, what happened? Is a negative, is EI 2 pi over 3. Z1 power 2, what do I get? Z1 power 2, what do I get?
Oh,
Is it okay?
you go.
Alright. Is it 1 over e to the power of 4 pi square over 9?
E power of I 4 pi over 9. Over 9 is wrong, over 3,
Oh, sorry, yeah.
right?
Yeah,
4
yeah.
pi over 3, right? So do you see that EI 4 pi over 3 is exactly our Z2? This is equals to Z2. Of course, Z1 power 3 equal back to 1. Because that's our questions here. Okay, there's the original questions. So what I can observe is Z1 power 2, it gives me Z2. What if I observe my Z2? Z2 power 1, EI 4 pi over 3. What about Z2 power 2? What do I get?
Does it rotate to 1 or something?
Something like that, but look at the angle carefully.
So it becomes 8 pi over 3.
Then what about this special about this 8 pi over 3?
It's the same as 2 pi over 3.
So it gives me back to Z1. Okay. Of course, Z3 power, Z2 power 3 equals to 1. So far, so good?
Yes.
Okay, this is a third observation. Number 4. Together with second observation and third observation. Second observation tells us that Z0 plus Z1 plus Z2 equals to 0. Okay, so now Z0 is 1. So I can also write this in the form of Z1 power 3. Z1, this is Z1 power 1. This is Z2. Z2 is here, isn't it? Z2 power 2 equals to 0, right? If we follow or if we write it in the form of Z1. Do you agree?
Yes.
So this will tell us that the sum of Z1 power of 1 to 3 will give me 0. Similarly, if I write in the form of Z2, Z2 power 3 will also equals to 1. Z1, this becomes Z2 power 2. Z2 is Z2 power 1. Will also equals to 0. This also tells us that summation of R equals to 1 to 3 of Z2 power R is also equals to 0. This is the result that you're supposed to get. That means other than Z0 itself, the power of the other roots will somehow equals to other roots, some other roots. Okay? And the summation of the one particular root with the power, okay, up to a certain sum will give you 0. Can you digest these 4 observations here?
Yes.
All of these different properties fall under the discussion of roots of unities. all come from DMT2. Okay. Let's see whether all of these four properties is it true for Z4 equals to 1. Okay. So first thing first, we want to write out the roots. So I have Z0, Z1, Z2, Z3. Okay. So this will be EI 2 pi over 4. This is 0, sorry. Then this is EI 2 pi over 4. This is EI 3 pi over 4. This is EI 4 pi over 4. Sorry. Did I write it wrong? I write it correctly or not? No, I write it wrongly. This is a 6. 2k pi. 2k pi. 2 times 2 with 4. This is a 2k pi. This is a 6. Agree so far?
Yes.
Okay. So then I can write them as a modulus argument form. So I have a cos 0 plus I sine 0, of course. Okay. Cos of pi over 2 plus I sine pi over 2. Okay. Cos of pi plus I sine pi. Then cos of 3 pi over 2 plus I sine of 3 pi over 2. Of course, we can actually write them as a real imaginary form. We have 1. This one I have I. This one I have a minus 1. This one I have a minus I. Do you agree?
Yes.
So what if we do Z0 power 1, Z0 power 2, Z0 power 3, Z0 power 4? This one, nothing special, isn't it? Because they are all 1, 1, 1, 1. Right?
Yeah.
Z1 power 1, Z1 power 2, Z1 power 3, Z1 power 4. Anything special about this?
It rotates again.
Z1 power 1 is I. Z1
Yeah.
power 2
Then
is
Z1 power 2
-1.
Z1 power 3.
is equal to Z.
-I.
Z1 power 4.
1.
So
1.
this is equals to Z0. This is equals to Z3. This is equals to Z2. This is equals to Z1, of course. Okay. If we look at Z2 power 1, Z2 power 2, Z2 power 3, Z2 power 4. What can we say about Z2 power 1?
-1.
Z2 power
1.
2.
-1. 1.
Okay. So this one, this is still, this will be equals to only Z2. This is Z not. This is Z2. This is Z not. So this one is not entirely true. So if we look at Z3 power 1, Z3 power 2, Z3 power 3, Z3 power 4. So z3 power 1, of course, is negative I. Is equals to z3 itself. But z3 power 2,
Negative
-1.
1.
negative 1. Negative 1 is actually z2. What about z3 power 3?
I.
So this one give me z1. z3 power 4, of course, is equals to 1.
1.
Okay. Sum of unity says, if I have a z0 plus z1 plus z2 plus z3, it gives us 0. This is true. Number 2, if I have a z1 power 1 plus z1 power 2 plus z3 power plus z1 power 3 plus z1 power 4, what can we say about this? This is still 0, right?
Yes.
This is still true. z2 power 1 plus z2 power 2 plus z2 power 3 plus z2 power 4. Although that it doesn't go to z1 and z3, but it still equals 0, right?
Yes.
Yes.
It's still true. z4, number 4, z3 power 1 plus z3 power 2 plus z3 power 3 plus z3 power 4. This is, of course, is still equals to 0. So it's still true for sum of all the other root other than z0. Okay? Wait for me. Okay. So, and from drawing wise, my z0 is over here, z1 is over here, z2 is over here, z3 is over here. Agree? What is this shape?
Yes.
What can we say about this shape?
Square.
Square.
It's a perfect square. Okay, so as you can see, it's a regular polygon. What can we say about the length and the angle?
The
They're
magnitude are all
yeah,
equal.
They are all equals to 1. The length equals to 1, and it becomes 90 degree, right? So it
Yes.
fulfills exactly whatever rule that we're actually talking about here. So therefore, the same thing will go for power 5, power 6, power 7. Okay, so power 3 gives you triangle, power 4 gives you a square, power 3 gives you a pentagon, power 6 will give you hexagon, and so on. Are you okay?
Yes.
With these properties, they can actually modify the question during fp2 exam, then to let you solve the questions. Okay, the difficulty of the question will be relying on the partial questions and the exercise questions. Okay, this part is called root of unity. This section is called your root of unity. Then I think, okay, we don't need to do so much first. I give you exercise 23C. Okay, so root of unity is not a definite exam questions, but if it's appear, of course, will be expected to you to know how to do. Okay, for exercise 23C. Duplicate. answer. Twenty-three Sing. Mm. 23 Sing. Okay, so I think I'll let you do the question first. I'll stop the recording here.